Morning everyone. A very good morning. Shall we begin the session? Yeah, yesterday's class was cancelled due to some technical issues. Yes. So today's topic is that previous topic I am taking out in the today's class, not an issue. That I'm not skipping that topic, but that same topic will be used over in the today's class. So that topic is attribute inheritance. So we are finished in the last class over here. That is, what are the various specialization, generalization method. Next one is attribute inheritance that I'm going to take in the today's class. So a crucial property of the higher and the lower end entities created by the specialization and the generalization, whatever takes place is known as the attribute inheritance. So when we talk about the attribute inheritance, that is done by using the attributes of the lower level entities, higher level entities that is inherited by the lower level entity sets. For example, when we talk about the student and the employee that inherits attributes of a person. Therefore, a student is described by its ID, name, and address attributes, and additionally a total credit attribute, that is employee, is declared by its ID, name, and address attribute. That means it is used with the various attribute that is defined with the ID, name, and address. Then when I talk about the attribute inheritance, that also applies to all tiers of the lower level entity sets. Lower level means that is inherited from the higher level attribute sets or the entity sets. Therefore, instructor and the secretary, which are subclasses of employee, inherits the attributes ID, name, and address from persons, in addition to inheriting or salary from employee. And a low-level entity set or the subset, that is also known as a subclass, also inherits the participation in the relationship set, in which its higher level entity, that means a superclass. So lower level entity is also known as a subclass, and the higher level entity is known as a superclass participates. Like attribute inheritance, participation inheritance applies to all tiers of the lower level attribute, whatever the lower level entity sets we are using. Now let's take an example. Suppose a person entity or the person entity set, or suppose a person entity set participates in a relation personal department with a department. Then the student, employee, instructor, and secretary entity sets, which are subclasses of let's take an example. Suppose the person entity set or the person entity set participates in a relationship person department with the department. Then the student, employee, instructor, a secretary entity sets, which are subclasses of the person entity sets, also implicitly participates in the person department relationship with the department. Therefore, whatever the above entity sets or whatever the new entity set that can participate in any relationship in which the person entity set participates. And whether a given portion of the ER model was arrived by the specialization or budget generalization, the outcome is basically the same. That may be high level entity sets with the attribute and relationship that applies to its low level entity sets. Then low level entity sets with the descriptive features that also applies only within a particular lower level entity set. So in what follows, although we often refer to only generalization, the properties that we discuss that fully belongs to both the processes. Now, when we talk about the figure 7.21 that depicts a relationship between the person, student, employee, instructor, secretary. So there's the specialization and the generalization over here. What is a person? That contains three attributes: ID, name, and address. Then employee, salary, that is attribute, student, total credits. Then employee have a two attributes or the two parts. One is the instructor, one is the secretary. Instructor have a one attribute, that is the rank. Secretary have a one attribute, that is the hours per week. So in this case, that generalization that person entity is in relationship with the department. Then the student, employee, instructor, secretary, entity sets, which are also the subclasses of entity sets, also implicitly participate in that relationship with the department. So these are the relationship that shows how one contain another, how the attributes are contained in another attributes. Now, what are the various constraints that is followed up on the generalization? Constraints means the foundations or the rules regulation. First is condition defined. That means to model an enterprise more accurately, the database designer may choose to place certain constraints on particular generalization. That means they focus on generalization. They are mainly to choose constraints on a particular generalization. And one type of constraint involves determining which entities can be members of a given lower level entity set. That means what entity sets may be a member, what entity set may be defined with a member of the low level entity set. Such membership may be one of the following. First is a condition based. In condition based lower level entity sets, membership is evaluated on the basis of whether or not an entity satisfies an explicit condition or predicate. For example, when we assume there is a high level entity set, student has attribute student type that I told you yes right now, and all these entities are evaluated on the defining student type attributes. So only those entities that satisfy that condition in which the student type is equals to graduate are allowed to belong to lower level entity set graduate student. And these entities must satisfy the condition that is the student type equals to undergraduate that are also included in an undergraduate student. And since all the lower level entities are evaluated on the basis of the same attribute, that is the student type, so this type of generalization is said to be attribute defined. Next one is user defined. So this defined or user defined lower entity sets are not constrained by the membership condition. Rather, it is used with the database user assigned that entities to a given set entities. This will assume with after the 3 months of the employment, university employees are assigned to one of our work teams. So we therefore represents a team as 4 level entity sets of high level employee entity set that is represented with the operation that add to an entity to the entity set. The second type of constraint is whether or not entities may belong to more than one low level entity sets. That means it is used a constraint for the lower level entity sets that may also belong with a single generalization. That can be any of the following. That may be a disjoint. That constraints require that an entity belongs to no more than one entity sets. In our example, student entity can satisfy only one condition for the student or the student type attribute. In this case, the entity can either a graduate student or undergraduate student, but cannot be both. Then overlapping, the same entity may belongs to more than one entity set or more than one lower level entity set within a generalization. For an example, consider the employee work team example and assume that certain employees participate in more than work team. So a given employee may therefore appear in more than one of the team entities set, the lower part of the employee. In this case, the generalization is overlapping. Overlapping means overruled with each other. And this assumes that a person can be both employee and a student. And we show that this overlapping generalization via separate arrows, one from employee to person, another from student to person, that is used with the generalization that is used with the instructor and the secretary that is disjoint with the single row. And a final constraint is used with the completeness constraint on a generalization that specifies whether or not an entity in the high level entity set must belong to at least one of the lower level entity set. That may include any of the following. One is the total generalization or the specialization. One is the partial generalization or specialization. That is a partial, that may be a generalization, that may be aggregation. Next part is aggregation. That is one of the limitation that it cannot express, or what is the limitation of ER model, that it cannot express the relationship between each other, or it cannot express what are the various relationship or among the relationship. So let's state the need for such construct. Consider the ternary relationship project guide, which we saw earlier. between an instructor, student, and a project. Now suppose that each instructor guiding a student on a project is required to file a monthly evaluation report. There is a monthly evaluation report that models the evaluation report as an entity evaluation with the primary key evaluation ID. Now one alternative for recording this one, that is a student project instructor combination to which an evaluation corresponds, is to create a quaternary, that is a four-way relationship set over four between instructor, student, project, and evaluation. This is used for the binary relationship between the student and the evaluation, that is used to represent the combination to which an evaluation corresponds. And using the basic ER modeling constructs, we have omitted the attributes for the simplicity. That appears that the relationship sets project guide and evaluation 4 can be combined into single relationship set. Nevertheless, we should not combine them into a single relationship since some instructor student project combination may not have an associated evaluation. That depends on the requirement of the person, that depends on the evaluation to the evaluation. Now, if the evaluation were a value rather than an entity, we could instead make evaluation a multi-valued composite attribute. Multi-valued means that contains more than one part. However, this alternative may not be an option for of an evaluation may not be related to other entities. That may be associated with the secretary who is responsible for further processing of the evaluation report to make scholarship payments. The next is aggregation, that is also an abstraction through which relationships are created as a high-level entities. Therefore, for example, we regard the relationship set project guide as a high-level entity set known as the project guide. In such case, entity is treated in the same manner as the entity with the another set. So we create a binary relationship evaluation 4 between project guide evaluation to which it represents with the combination of the evaluation. So this shows a notation of the aggregation commonly used to represent this condition. So there is a project instructor, then project guide student evaluation for the evaluation. Now how it is reduced to the relation schemas. One is a representation of the generalization that may be included with the ER diagram, that may include generalization, representation. Now the next part is representation of the generalization that contains two parts, or there are two different models of designing the relation schemas in which it is defined for an attribute for an ER models, ER diagram that includes the generalization. Although we refer to the generalization in this discussion, we simplify it by including only the first tier of the low-level entity sets, that is employee and the student. So we assume that ID is a primary key of a person. So create a schema for the low-level entity set first of all, and for each low-level entity sets, create a schema that includes an attribute for each of the attributes of that entity set plus one for each attribute of the primary key of high-level entity sets. So in this case, it is used with the figure 7.21, that is used with the person's project, guide, student evaluation. The next alternative representation is also possible if the generalization is disjoint. That is, if no entity is a member of the two lower level class entity set directly below the high level entity set, and if every entity in the higher level entity set is also a member of the one of the low level entity sets, here we do not create a schema for the high level entity sets. Indeed, for each low level entity sets, we create a schema that includes an attribute for each of the entity that includes each entity of the higher level. That means it includes the low level entity sets plus the high level entity sets. Therefore, then for ER diagram, we have two schemas. One is employee, then ID, name, street, city, salary. Then student, ID, name, street, city, total credits. Both these schemas have ID, which is the primary key attributes of the low level or high level entity set person as their primary key. One drawback of the second method lies in defining foreign key constraints. So to illustrate this problem, suppose we had a relationship set R involving the entity set person. With the first method, when we create a relation schema R from the relationship set, we should define a foreign key constraint on R that referencing the schema person. And unfortunately, with the second method, do not have a single relation to which a foreign key constraint on R can also refer. So to avoid this problem, we need to create a relation schema person that containing at least the primary key attributes. At least means that is possible for the primary key attributes of the person entity sets. And if the second method were used for overlapping generalization, some values would be stored multiple times unnecessary. And if a person is both an employee and a student, value for street and the city, that should be stored twice. And in this case, if the generalization were disjoint but not complete, that is some person is neither an employee nor a student, then an extra schema, that is a person, ID, name, street, city, that may be required to represent such people. However, the problem with the foreign key constraints mentioned above would remain the same, and as an attempt to work around the same problem, we require that the employee and the student are additionally representing in the person relation. And unfortunately, name, street, city would then be stored redundantly in the person's relation, and the student relation for students similarly in the person relation, and the employee relation for the employees. And if we do so, the result is exactly the same for the student and the relationship for the student and the employee. And if we do that, the result is exactly the same method that we represented. Then next is representation of the aggregation. So designing the schemas for an ER diagram also containing the aggregation, that is very straightforward for the aggregation for the relationship that is used to evaluate for between the aggregation of the project guide entity set relationship. The next is alternative models or notation for the ER diagrams. Now, what are the various alternative ER diagram models that is used? So there is a diagrammatical representation. One is used with the various experts in which number of alternative notations are representing that have been proposed, of which ER diagram and UML class diagram are mostly used. This is one of the entity set E, then R relationship set, then identifying the relationship set for the weak entity set, then total participation of entity set in the relationship, then many-to-many relationship. This is many-to-many relationship. Then attribute simple or simple A1, A2, multi-valued derived. So this is a one-to-one relationship. This is many-to-many. This is many-to-one relationship. This is a cardinality limits. This is the role indicator. Then is a generalization or the specialization, then total disjoint generalization, then disjoint generalization that is used with the E1, E2 and the E3. So this is used with the sixth edition of that actually differs from the notations we used in the earlier sections for reasons that we explain later in this sections. In this section, we are going to represent what are the various alternatives for the ER diagram notations as well as the UML diagrams. Now, this UML diagram I'm going to take within the next class, that is in the tomorrow's class. So till now, till relationships, till this alternative approach, any doubts anyone in the assignments, in these grades, these additions. So there are a variety of tool that is also used for constructing the ER diagram. So any doubts, anyone? If you have any doubts, then please clarify the doubts. Yeah, that modeling technique will be used. One of the modeling technique is ER diagram that we have discussed. One is a UML, that is a unified modeling language that we discuss in the next class, that is in the tomorrow's class. And I'm asking about till now any doubts, not UML.